evaluate the integral from 0 to pi halves of cosine of x times sine of x dx. Well, now we're starting to get fun. We're going to need to make a substitution here, and the composition of functions, sine of x, has an inner function of sine of x. So let's let u be sine of x. That means du is cosine of x dx. And luckily for us, we do have a cosine of x dx there. So we can replace all of that with du. And so this is going to end up being the integral of sine of u du. Sine of u, because we're plugging in u for sine of x. And then cosine x dx gets replaced with du. And then we just have to change our limits of integration. So the upper limit was x equals pi halves. And we know that our substitution was u is sine of x. So that's going to be u is sine of pi halves. And sine of pi halves is 1. Our lower limit is 0. And so we've got sine of 0, which is just 0. So our new limits are going to be from 0 to 1. Now we can integrate. The integral of sine is negative cosine. So we've got negative cosine of u evaluated at 0 and 1. So that is going to be negative cosine of 1 minus negative cosine of 0, which is the same as negative cosine of 1 plus cosine of 0. Now, cosine of 0 is 1, but we don't know what cosine of 1 is. That's not a nice angle. We could use a calculator to get an approximation, but if we're not asked for that, we should leave it exactly as it is. So this is negative cosine of 1 plus 1, which we can write as 1 minus cosine of 1. That is our exact answer. You could use a scientific calculator to get an approximation for that. If you did, you want to make sure you're in radian mode, not degree mode. But because we weren't asked for an approximation, I'm not going to give one. I'm going to leave it just like it is.